The last section in section 3.4 is graphing a polynomial function, and we've got all the stuff from the previous sections, from the things we've learned in this section, to graph a polynomial function. So let's get some guidelines to figure out how to approach this. So first we want to determine the end behavior. Next we want to find the y-intercept. That's always an important point to plot. And then we want to find the zeros. And the zeros is where we have many, many options to figure out what they are. There's the rational zeros theorem. There's the factor theorem. We have the remainder theorem. We have tests for 1 and -1. And if you want to refer back to that, that's on page 247. We can also use factoring if we have something that's quadratic, or we can factor by grouping, something like that. And then we also have the quadratic formula. Then we're going to use the y-intercepts, the end behavior. We're going to use the multiplicity of the zeros. And any points that we found in between intervals to sketch our smooth and continuous curve of our polynomial. Now there may be some other things that we can throw in there: polynomial zeros theorem, complex conjugate theorem when we get to complex factors, number of turning points, Descartes' rule of signs, the upper and lower bounds, and symmetry. All of those things can help us graph. So let's take a look at an example. And we want to sketch the graph of g of x is equal to 2x cubed plus x squared minus 5x plus 2. And let's start off with the end behavior. And if we take a look, we know that our degree is odd, because our degree is 3. And we know our leading coefficient is 2, which is positive. So based on that information, we know we're going to go down on the left, and we're going to be up on the right. Okay, next we'll calculate our y-intercept. So we're going to have g of 0 is equal to 2 times 0 cubed plus 0 squared minus 5 times 0 plus 2. And you can see, since this is in standard form, everything's going to cancel out except for our number at the end. So this is going to give us g of 0 is equal to 2. Our y-intercept is 0, 2. Okay, finding our zeros. This is where we have a lot of different choices, but we're going to start with the rational zeros. So we have the factors of 2 divided by the factors of 2. So that's plus or minus 1 and plus or minus 2 over plus or minus 1 over plus or minus 2. So that leaves us with plus or minus 1, plus or minus 2, and plus or minus 1/2. So that kind of narrows down where we need to look. And since plus or minus 1 are options, let's do the test for zeros. So let's test for 1, which means take all the coefficients and add them up. So we have 2 plus 1 plus -5 plus 2. And if we add those up, we get 0. So therefore, 1 is a 0. So we found 1 already. Okay, let's do the test for -1, which is very similar, but for all the odd-powered terms, we have to flip the sign, or take the opposite sign. So that means we're going to have -2 plus 1 plus 5 plus 2. And if we add those all together, we end up with 6. So that means -1 is not a 0, But this did give us some information. We now know that -1, 6 is a point on our graph. Okay, so let's use some synthetic division, see if we can help us narrow this down a little bit more. So our coefficients are 2, 1, -5, and 2. And we know we have a 0 at 1. So let's try to at least get that factor out. So we'll bring down our 2, multiply, add, multiply, add, multiply, and look there, we get a 0. So our test for 1 did work. So we know that x minus 1 is a factor. Now for our test of -1, we know it's not a factor, but let's use these results and let's pick another number from our list of possible rational zeros. So we've done 1 and -1. Let's pick +2. So we're going to take our results and we're going to try 2. So again, add, multiply, and then add. Oops, our remainder is not 0. So that means x equals 2 is not a 0. But that does tell us that 212 is a point on our graph. Okay, let's go back to our results that we had here, and let's rewrite those. Pick a different color here. So I'm using 2, 3, and -2. And let's see if -2 is a factor. So add, multiply, and look, we get a 0 as our remainder. So this is telling us that x plus 2 is a factor. So now we have a function, g of x, that we can write in factored form. So we know x minus 1 is a factor. We've just found out that x plus 2 is a factor. And then if we look at what we have remaining, we have 2x minus 1 is a factor. So that gives us our zeros of x is equal to 1, x is equal to -2, and if we solve the last one, we get x is equal to +1/2. So now we have zeros, we have end behavior, we have a couple points in between. Let's go back up to our graph and let's graph these. Okay, so we know we have 1 is a 0, -2, and we have a 1/2, which is in here. Okay, we also have our y-intercept, which is 0, 2, which is right here. And then we found a couple other points. We're only going to plot one of those. We have -1, 6. That's just a little bit above what we have here on our graph. And the other point we found was over here, 212. That's not going to fit on our graph, but I think we have enough to see what's going on here. So for our end behavior, we're starting down on the left. So we're going to go through this 0. We'll go all the way up here to our point, go through our y-intercept. Here we have another 0 and another 0. We need to curve back around, and we are ending on the right. And let's just double check to make sure we have all of our multiplicity right. Yep, all of these have a multiplicity of 1, so they go through at each one of those points. So there is our graph.